Vijnam Mahavishtum Jwalantam Sarvatomukham Nrsingham Bhisanam Bhadram Murtyum Namamyam. Dear students, we have discussed the theory of electromagnetic radiation and Planck's quantum theory in order to overcome the objections raised on the Rutherford model of atom. The Niels Bohr in the year 1913 proposed a model of atom called as the Bohr model of atom. We are now going to discuss the Bohr model of atom, which is based on his theory called as Bohr theory. So, in order to overcome the objections raised on Rutherford model of atom, what are the objections raised? The first objection, the electron is a negatively charged particle moving around the positively charged nucleus ought to radiate energy, hence the energy of the electron will constantly decrease. As a result, the force of electrostatic attraction between the nucleus and upon the electron will be more and more than that of the centrifugal force due to the circular motion of the electron at every point on the orbit. As a result of this, the electron will have an angular acceleration toward the center. Its radius will steadily decrease. It will no longer move in a circular path, will attain a spiral path and plunge into the nucleus. So then what is happening here? The Bohr has made an attempt. Take the Planck's quantum theory of electromagnetic radiation. Considering the Planck's quantum theory, he applied the Planck's quantum theory and some restrictions upon the electron. Because the Rutherford was a very democratic. He proposed the electrons are moving around the nucleus in circular orbit. He has never told how many orbits are there and how many electrons can move in the orbit. He did not impose any restriction upon this. Then second thing, when this objection was raised, then the atomic spectrum was studied. If the objection raised on Rutherford model of atom is correct, then there should be a continuous line in the atomic spectra. But surprisingly, it was found that there was no continuous line. The lines were discontinuous in atomic spectrum. So that again a question. That means the theory which objects Rutherford model of atom is also has to be revised. Hence, the very intelligently the Danish scientist Niels Bohr in the 1913 proposed his model of atom known as Bohr model of atom to overcome all the objections and explain the atomic spectrum perfectly. Not only that, by the Bohr model of atom he could calculate the capacity, he could propose the capacity of cells, calculated the radius of an orbit, the energy of an electron, the velocity of an electron, and could perfectly explain the hydrogen spectrum. Hence, this Bohr model of atom was widely accepted. Till today also, whatever postulates the Bohr has taken with the proper modifications, still all elementary calculations are made by Bohr model of atom. So, what is that Bohr model of atom? Now we are going to study. So, in the year 1913, the Danish scientist scientist, the Danish scientist Niels Bohr, Danish scientist Niels Bohr proposed his model of atom called as the Bohr model of atom. Then what are the fundamental postulates of Bohr model of atom? He has proposed in postulates. So the fundamental postulates of Bohr model of atom are as I am discussing them. First postulate, he says the electrons are moving in closed concentric circular stationary orbits called as cells. You see how are the restrictions is imposed. He says the electrons are moving in closed, means there is no question of the orbit getting opened, having a spiral path, and the electron to plunge into the nucleus. So closed. In the model of atom in which I am proposing, my orbit will never open. It is closed for all time to come. The orbit in which the electron is moving, it is always closed. Then he says concentric. There is not one orbit. There are many orbits with the same center. The nucleus, called cells. So the nucleus is there at the center. What Rutherford has proposed, he accepted that. He accepted the circular orbit of Rutherford. He accepted that the nucleus is placed at the center of the atom, and he accepted the nucleus consists of the protons. He has not overruled the Rutherford model of atom. He has accepted all the essence of Rutherford model of atom. So the nucleus is placed at the center, and there are cells, many cells with the same center, and they are circular and stationary. Means there is no question of the orbit to move from one point to the other point. What was we have discussed that it is moving like this and spiral path plunge into the nucleus. That was the objection raised upon the Rutherford model of atom. He says the orbits are stationary, the electrons are moving, and he called them as cells. Orbit, what is an orbit? Orbit is a cell. Cell, if you know the cell, the prisoner is in his cell in the prison. The prisoner is in his cell in the prison. Means what? He is numbered. Suppose his chest number is 18, he will be remaining in cell number 1, and he cannot come out of the cell, cannot go to anywhere inside the jail. He will be there for all to come. Anytime anybody can go, can find out that particular prisoner in that one. Fixed. He cannot go to any other room. And cell means, that is a word cell he has used. So he has to emphasize the orbit, he has used that cell. Means it is fixed. Everything is fixed in that. So that is called a cell. So then the electrons are moving in closed, concentric, circular, stationary orbit. A student may say, he proposed the electrons are moving in closed, concentric, circular, stationary are called as cells. So any student, if he says, how do I remember this? You can remember like this, C, 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 S. You keep in your mind C, 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 S. Closed, concentric, circular, stationary orbits. C, 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 S, O if you remember, then you can tell us very easily, you will not forget a single word. The electrons are moving in closed, concentric, circular, stationary orbits called as cells. That means what? Here is a nucleus. Nucleus is there in which the protons are placed, and there are cells. This is one orbit, this is another orbit, then another orbit, concentric with the same center. They are circular orbits, so they are called as closed, concentric, circular, stationary orbits. So this is the nucleus and these are the cells. Then he wanted to explain this cell. He want to signify what is cell. Then he says the cells are definite energy labels. Definite energy labels arranged in the increasing order of energy away from the nucleus. Away from the nucleus, designated by the letters K, L, M, N, etc. You see how nicely he has proposed the thing. He says the electrons are moving in closed, concentric, circular, stationary orbits called as cells. Then what are the cells? He wanted to explain what are these cells. The cells are definite energy labels. Each orbit has a definite energy. That means the energy of the energy of two orbits will never be identical. They will not be identical. They have different energy. Then how are they? They are arranged in the increasing order of energy. They are arranged in the increasing order of energy away from the nucleus. Means when you go from the nucleus, from first cell to second cell, the energy is increasing. From second cell to third cell, the energy is increasing. The third to fourth cell, the energy is increasing. That means the energy moving, the energy of the electron moving in the fourth cell is more than the energy moving in third cell, then in second cell, then the first cell. So he says this is the nucleus, is placed at the center of the atom and the cells are there. These are the cells. So this is one cell, then another cell, concentric with the same center, they are there. So like this, closed, concentric, circular, stationary orbits called as cells. What is this? So this is K cell, then L cell, then M cell, then N cell, and this is the nucleus. Then how are they? If you increase the energy, so this is the energy, so this is the K cell, then the energy L cell, then the energy M cell, then energy N cell, then energy O cell, like this. As you go, the energy of the orbits, the energy of the cells are increasing. The electrons are moving in closed, concentric, circular, stationary orbits called as cells. The cells are definite energy labels arranged in the increasing order of energy away from the nucleus, designated by the letters K, L, M, N, etc. So now, in the third postulate, what has been done? He has imposed restrictions upon the electron. He has imposed restrictions. The third postulate is the energy of the electron, while moving in a cell remains constant. Remains constant. That means if the electron is moving in K cell, its energy will remain constant. L cell remain constant. They cannot. So hence, the cells are called as stationary states. They are called as stationary states because everything, what is stationary? Anything is fixed. The sun is stationary and the earth is moving around the sun. We say the sun is stationary, the earth is moving around the sun. Means sun is not moving, the earth is moving around the sun. So stationary means nothing will change. It is intact, it's fixed, it's rigid. All these things are there. So that is the reason the cells are called as stationary states. The electrons, the energy of the electron while moving in a cell remains constant. What was happening? What was this is a restriction he has imposed upon the electron. What was the objection? The objection was the electron is a charged particle moving around another nucleus charged particle, hence will radiate energy. No. He says the electron cannot radiate energy, its energy remains constant. If it moves in a cell, in that cell, the energy of the electron will remain constant. So this is the way he has imposed restrictions upon in order to overcome the objections raised under the fourth module of atom. He has imposed some restrictions upon the electron and upon the cells. So the cells are, that is called, they are called as stationary states. Then again he says what? An electron, the fourth postulate, an electron while moving in a cell, cannot radiate or absorb energy of its own accord. That means the electron, that the energy of the electron remains constant while moving in a cell. There is no freedom for the electron to emit energy or absorb energy unless we supply energy. If we will supply energy, then electron will accept energy. Or if we withdraw energy, the electron will lose energy, but the electron cannot radiate energy of its own accord. The electron cannot radiate an electron while moving in a cell. So that conforms the stationary. That is the reason called the cells are called as stationary states. That is the reason he used the word, a very wonderful word he has chosen. There are stationary states. That means the energy of the electron remains constant. There is no question of the electron to emit energy or absorb energy while moving in a particular cell. Now then question comes, he wanted to explain what is the how many electrons can remain in one cell. What is the capacity of a cell? So how the electrons will be distributed? Because an atom has 1 electron, an atom may have 10 electrons, an atom has 20 electrons, an atom has 90 electrons. How these electrons will be distributed? How many electrons one cell can accommodate? To explain that, fifth postulate, the maximum capacity of a cell to accommodate electrons is 2n square. The capacity is 2n square, where the n is the principal quantum number. He used a term here, principal quantum number, as I said, the principal quantum number. The principal quantum number PQN I am writing means what? Principal quantum number can have any non-zero positive integral values such as 1, 2, 3, 4, etc. He is called principal quantum number, means this number is a principal. This number is a principal, means everything. What do you mean the word principal? The principal of a college. The command comes from the principal. The rules and regulations are imposed by the principal. The order is issued by the principal. Whatever he says, that is correct, or everything is derived from him. So here also this number n, this number n, this means the n is the principal quantum number. From this n, everything, n can explain everything. N can explain everything. So here very nicely he has chosen the words. That is the reason he called n as a principal quantum number. It is a mukhya, principal secretary of a department. There are many secretaries in the department. Then come the principal secretary of the Chief Minister of Odisha. There are many secretaries under the Chief Minister of Odisha. That secretary gives the command to all the secretaries according to the will and pleasure of the Chief Minister of the Odisha or the government. So he decides everything. Everything is final with him. So this number is important number. Hence he called principal quantum number. Everything in the model of atom is derived from the letter n. So he says the maximum capacity of a cell to accommodate electron is 2n square, where the n is the principal quantum number. The principal quantum number can have any non-zero positive integral values as 1, 2, 3, 4. Then in the same thing he says, when in the same thing he says, when n equal to 1, 2, 3, 4, etc., the cells are K, L, M, N, etc. So when n equal to 1, 2, 3, 4, 5, 6, 7, 8 like this, the cells are K, L, M, N, etc. So the capacity, and accordingly capacity, now what is this K? When this n is equal to 1 is K cell, n is equal to 2, it is L cell, n is equal to 3, it is M cell, n is equal to 4, it is N cell. So now if you say the principal quantum number P, Q, N, I am writing this N 1, 2, 3, 4, then cell will be K, L, M, N. Then capacity of the cell is 2n square, is 2n square. So n is equal to 1, so 1 square is 2. And n is equal to 2 square, it is 8. And n equal to 3 square, it is 18. N equal to 4, 2n square, it is 32. So that means the capacity of the cell is 2n square, he says. So the capacity of K cell will be 2. The capacity of L cell is 8. The capacity of M cell is 18. And capacity of N cell is 32. Under no circumstances K cell can keep more than 2 electrons. Under no circumstances the capacity, the L cannot take more than 8 electrons. M cannot take more than 18 electrons and N cannot take more than 32 electrons. So that way he can distribute the electron. When the atomic number is 30, then he will go on 2, then 8, like this he will go on adding. Suppose the atomic number is 10. So first cell will take 2 electrons, then remain 8 electrons, it will go into second cell. Now suppose there is 18. Atomic number is 18. So there are 18 electrons. So first cell will take 2 electrons, then second cell take 8 electrons, then third cell will take 8 electrons. So that is the way how the electrons can be distributed among the cells. So then he has the maximum capacity of a cell 2n square. When n is equal to 1 K cell, capacity 2, n equal to 2 L cell, capacity 8, n equal to 3 M cell, capacity 18, n equal to 4, capacity 32. Like this, he could say the capacity of he could explain the capacity of a cell. The cells are arranged. Now the electrons are moving. The electrons cannot radiate energy or cannot observe energy of their own accord, and the cell, the cells are numbered by the principal quantum number, n equal to 1 K cell, L cell, M cell, like this. Now question comes, can the electron move or not? Can we take, if we want, then what is electron? Electron is a charged particle. And what the electron is doing? It's moving with a velocity v. It has its mass m. So it will have a kinetic energy half mv square. It will have a kinetic energy half mv square, and it will have potential energy because of its position. So now, by some chance or other, if the electron is moving in K cell, to that electron we will add energy. So he cannot move in this K cell because his energy increased. He will go to that cell. He will go to that cell with which the energy of the electron is equal. So that is the way he has says. He says that electron cannot radiate or observe energy of its own accord, but he has proposed. Why did he propose this? Because he found there are lines. There are many lines in the atomic spectra. And in order to explain that atomic spectral lines of hydrogen atom, keeping an observation, always conclusion comes in the experiment from the observations. Experiment is carried out, observation is made, then conclusions are made to explain the observations which confirm the theory. So he has proposed a theory to explain the spectral lines. So to explain those spectral lines, keeping those spectral lines in his mind, and taking the help of the Planck's quantum theory of electromagnetic radiation, he has proposed certain postulates, and those postulates constitutes as a Bohr theory. That is called as a Bohr theory, which explains the Bohr model of atom. Now then comes, then what the next, he says, when an electron is made to observe energy, gets excited, jumps from lower energy level to higher energy level. While the electron is moving in his cell, that is called ground state of the electron. When the electron is moving in his cell, that is called ground state of the electron. When the electron is moving in K cell, it is in its ground state. When the electron is moving in L cell, it is its ground state. When electron is moving M cell, it is its ground state. So in the ground state of the ground, I am standing on the ground, means I am very stable. I am very stable when I am standing on the ground. The moment I come up, if I stand on a table or stand on a ladder or stand on a chair, I am unstable. So here, suppose I am there and I got an information, some information is given to me. that I won a lottery. So then I lose my ground state. Immediately the idea goes to my mind, I have won the lottery. Then I rush to the counter to verify. Many things will happen to this. I got excited. Or if somebody is there, you are telling some wrong things to him which he doesn't like, then he loses himself. He loses his ground state and gets excited and goes on telling anything according to the thing which is proposed to him. That is called excited. Children, please, I will be appealing you. You are learning chemistry and you can learn better chemistry when you understand the words used by the author when he has used them to explain that. Many often we are remembering the postulates and you are forgetting. And once you understand those words, why this word is used, why not some other word, excited, means losing its ground state, so goes from lower energy level to higher energy level. Because why? An electron, while moving in a cell, remains in energy. So then comes, then when the electron is made to radiate energy, made to radiate energy, jumps from higher energy level, higher energy level to lower energy level, to lower energy level. Means what? Suppose this is a cell, suppose this is a K cell. Energy, this energy is increasing. K cell. This is the L cell. This is the M cell. This is the N cell. K, L, M, N. The cells are like this. Suppose the electron is moving in K cell. Now we add energy. It will jump from this orbit to the other orbit. It will come from this cell to this cell. It will not stay in the middle. You see, gets excited from jumps. I am using the word jump. Why? He wanted to explain the discontinuity of the spectral line. Means he observed in the spectrum one line, then another line, then another line. So there is no line. Means what? These energies, they are explaining energy levels. So the electron jumps from this place to this place, or this place to this place, means they are the energy levels. Why? According to the theory, you know, E equal to h nu, and nu is the frequency, and this is equal to h into c by lambda. So the energy is related to lambda. Lambda is the wavelength. According to wavelength, we get the spectral lines. Spectral lines. So when electron jumps from one orbit to the other orbit, not walking, not running. If running means it will put the steps in between. There is no in between step. From one cell to the other cell, the electron goes. So he says jumps from one or suppose you apply energy, more energy, and this electron will go straight to M. It will not go stay at L. If you give the energy equal to the energy of M cell, it will jump from K cell to directly to M cell. Suppose the electron is moving in N cell and it's made to lose energy. So this will fall down to K cell if its energy becomes K. Or if it loses energy equal to M cell, then it may fall down to M cell. Not that when the energy he will fall down and to the ground. No. According to the amount of energy removed from it, according to that, it will move in. So an electron moves in a cell, in a cell equal to the energy of the cell. He will move in that, the electron will move in that cell whose energy equal to is the energy of the electron. So these are the way he is using some restrictions. He has not given any independence to the electron that he can, the electron can go of his own accord, the electron can move of its own accord. Electron is moving around the nucleus but cannot move of its own accord. So now then question comes, then how much energy an electron will observe, or how many energy an electron has to radiate to jump from one cell to the other cell. There he has used the Planck's quantum theory of electromagnetic radiation. In my next class, I will explain you what is the amount of energy the electron has to absorb to jump from lower energy level to higher energy level, and what the electron, how much energy the electron can emit out, come from higher to lower level. That we will be discussing in our next class, and we can calculate the other things about the Bohr model of atom.